In this first exercise, we're going to use the Excel financial functions, but from the point of view of loan calculations. These are useful to be comfortable with, but also they give you good practice in applying them in real-world situations. And property finance is certainly one of the issues that you'll have to deal with from time to time in your modelling. Let's look now at how we model a simple mortgage loan. Let's work down what has to be calculated. The first thing we have to do is work out the total number of payments. These are the total monthly payments. To do that, we're going to insert an equation which is equals 25, with the number of years, multiplied by 12, which is the number of months in a year, and it gives me 300. And by entering 300, the yellow highlight disappears, telling me that I have the correct answer. Likewise, the monthly interest rate. Here the monthly interest rate is simply going to be the annual interest rate divided by 12 months. Now this is the simple nominal monthly interest rate, and I use nominal interest rates because that's what banks use when they're working out loan calculations. It actually makes the banks a little tiny bit more money than if they were to use effective interest rates. But most borrowers don't notice, and the banks are quite happy. Let's look now at working out the monthly repayment. To do that, I'm going to use the Excel PMT function. That's PMT, open brackets. Now we're going to enter the rate, which is the 1% that we've calculated per month, comma, the number of periods, which is 300 months, comma, and we're going to put a negative in to correct the sign conventions in Excel. We're going to put the present value, which for the loan is the amount that we borrow, and here I don't need to put any more parameters in, so I'll close the brackets, and that gives me a monthly repayment of $3,686, and so on. I can work out the total repayment by simply multiplying the monthly repayment times the number of months, which gives me an amount a bit over $1 million. To work out the total amount of interest that I've paid, it's done a little bit indirectly, but it's simply done by subtracting from the total repayments the actual amount that's being paid off the loan, which is the loan principal of $350,000. And so with that 25-year loan, I've repaid about $1.1 million. $750,000 has been in interest, and $350,000 is the actual repayment. So that is, we're paying back roughly about 2 times the actual principal in interest, or 1/3 of my repayments actually turns up as repaying the loan itself. The next thing I want to show you is how to calculate how much is outstanding at any particular time through the loan. Now this is a tiny bit tricky, but once you learn how it's done, you'll find it very easy to apply in other cases. I'm only going to do it once here. I'm going to let you do the rest of the calculations yourself. The way you work out the principal sum part into loan is to work out what the PV is of the remaining cash flows. So I'll show you how that's done. Equals the present value of, now I'm going to use the rate of 1%. Here I'm going to say the number of periods is equal to 300 minus 5 years of repayment. 5 times 12, comma, put the negative sign to get my sign convention corrected, and my monthly repayment. And so what I'm saying is that to work out the principal outstanding, how much I still owe on the loan after 5 years of repayment, is done by, in this case, calculating the present value of 20 years of repayments. Let's see what that works out to be. So what that tells me is that in the first 5 years I've paid back, well, what's that, about a bit more than $15,000. I'll let you correct out the yellow highlights here for the 10 and 15 in your own time. Likewise, to come down here and work out how much principal I've paid, I again do that with a simple subtraction. I say I started off with a loan of $350,000. I have now an outstanding principal of 334, and so that means I only have paid $15,000 despite having paid many times that in loan repayment. I'm going to leave you to calculate the remaining options for the 10 and 15 years. I want to move now down to the accelerated repayments. In the question, you'll notice that the situation is calling for analysis of what happens if I repay the loan a little bit faster. And so the amount faster is going to very simply be equal to the basic repayment multiplied by the factor of increase, which is going to be 1 plus the 10%. If I'd simply put in here the original repayment times 1.1, I'd still get the same answer. However, if someone was to change the 10% to 20% or 50% or something, my equation would not work. And so by always putting in the cell addresses when I have data implicitly being referred to, it makes sure that my model works for all cases. To work out how long the loan is going to take to pay off under this new higher repayment, I'm going to use the Excel function of NPER. Let's do that. NPER, open brackets, and it's a function that looks fairly similar to the PV function, except that you'll find, looking closely, the parameters are a little bit different. I'm still going to have the rate. In this case, I'm going to have the payment. I'm going to put a negative sign in there to say that it's a negative amount of money. The PV is still the $350,000, and with that I should be able to close that out. And that tells me that instead of the 300 months previously required, I only need 100 and, well, close enough to 200 months. So I've saved about 1/3 of the length of the loan by taking this higher repayment. If I work that out in terms of years, it's simply going to be that divided by 12. The total repayment here is going to equal the number of repayments, and I'm going to work this out exactly, even though I won't actually be working out a 0.12 payment. I'll be simply making a balloon payment at the end. It's going to be the total repayment is the number of repayments multiplied by the repayment amount. That's going to mean that my repayment now has come down from 1.1 million down to only 810,000. In other words, I've saved, well, I can work that out. I've gone from 1.1, now I'm only paying 810,000. And what we see is that there's something like almost $300,000 saved. You'll notice that that is all in terms of saved interest, because we're simply paying back the full principal in both cases. And I'll leave you to work out the progressive repayments at different periods through the loan. You will notice, however, that the major improvement tends to be in the earlier parts of the loan, but I'll leave that for you to discover. Let's move now to the next exercise.